process begins by converting raw desert terrain into a controlled agricultural base. Compacted ground is broken and leveled to define planting geometry, while trenches are excavated to install irrigation infrastructure. High-density pipelines distribute filtered water and nutrients from centralized pumping systems, and surface drip networks regulate delivery across planting rows. Once pressure stabilizes and flow begins, the environment shifts from unmanaged land to a fully regulated growing system. With infrastructure active, biological systems are introduced. Soil is conditioned to support root development, and grafted young trees are positioned within prepared sites. Each tree is stabilized and irrigated immediately to support underground adaptation. Protective measures reduce environmental stress while root expansion begins. At this stage, living plant systems become structurally integrated with the engineered environment. As vegetative growth progresses, structural development is actively controlled. Pruning directs branch architecture, trellis systems stabilize alignment, and competing growth is removed to regulate resource allocation. Irrigation and nutrient delivery respond to monitored soil conditions. Individual trees gradually connect into a continuous canopy structure, optimized for airflow, light distribution, and mechanical accessibility. During dormancy, biological activity slows while structural maintenance continues. Pruning removes non-productive wood and preserves canopy balance. Organic residue is recycled into mulch to protect and enrich soil layers. Irrigation shifts to preservation levels, and soil amendments restore nutrient composition. Mechanical systems are serviced and recalibrated, preparing both soil and infrastructure for renewed growth. Seasonal warming initiates reproductive development. Bud expansion leads to flowering, and pollination ensures fertilization across the orchard. As blossoms transition into early fruit formation, the biological focus shifts from structural growth toward yield production, establishing the foundation of the harvest. Developing fruit is regulated to ensure uniform growth. Selective thinning controls density and resource distribution, while irrigation and nutrient supply increase to support metabolic demand. Pigmentation deepens and protective surface layers form. Measured parameters such as size and sugar concentration determine harvest readiness, ensuring consistent maturity before removal. Harvest operations convert biological yield into transportable material. Mechanical vibration detaches ripe fruit, while integrated catch systems prevent impact damage. Conveyors remove debris and guide fruit into collection containers. Rapid transfer from orchard to transport units preserves structural integrity and internal quality. At the packing facility, fruit enters controlled unloading systems and passes through multi-stage cleaning and drying. Optical inspection classifies product by size and condition. Approved fruit is weighed, packaged, labeled, and palletized, preparing the harvest for controlled storage and movement. Temperature stabilization begins immediately after packing. Pre-cooling removes field heat, and refrigerated storage maintains consistent internal conditions. Continuous monitoring preserves structural and biochemical stability throughout transport, linking orchard production to downstream processing and market distribution. Processing facilities receive the fruit as regulated raw material. Each batch undergoes verification through sampling and analytical inspection. Only compliant lots enter the production system, maintaining traceability and consistency from harvest to processing input. Industrial sanitation removes residual contaminants before mechanical separation eliminates inedible components. The material is standardized into uniform processing units, enabling controlled distribution into multiple production lines. Prepared fruit undergoes controlled dehydration. Regulated airflow and temperature gradually remove moisture while preserving structural stability. Once preservation thresholds are achieved, the product is inspected and packaged for long-term storage. Mechanical extraction separates liquid content from solid structure. Clarification, stabilization, and thermal treatment prepare the juice for sterile filling. Sealing and cooling complete the transition from fresh fruit to packaged liquid product. Refined fruit material is concentrated through controlled heating until viscosity develops. Moisture reduction and sugar integration stabilize texture. The product is filled hot and sealed to maintain preservation. Clarified juice undergoes staged evaporation to remove water and increase solids concentration. Sterilization and cooling stabilize the concentrate before sterile storage for industrial use. Laboratory monitoring verifies chemical composition, microbiological safety, and physical consistency across all product streams. Integrated data systems maintain uniform production standards. Automated cleaning systems circulate chemical and thermal treatments through internal equipment surfaces. Pipelines and processing units are restored to hygienic condition, enabling uninterrupted production cycles. Finished goods are grouped, secured, and transferred to controlled storage. Automated handling systems coordinate routing through distribution networks toward domestic and international markets. final products enter everyday consumption while new harvests begin the same sequence of cultivation, processing, and distribution. Agricultural production and industrial transformation operate as a continuous, repeating system. The process begins by transforming raw desert terrain into controlled agricultural foundation. Compacted soil is broken and leveled to establish planting geometry, while trenches are excavated to install irrigation systems. Underground pipelines distribute filtered water and nutrients from centralized pumping stations, and surface drip networks regulate delivery across planting rows. Once flow stabilizes, the desert is no longer passive land. It becomes a managed environment designed to sustain continuous biological growth. With infrastructure operational, biological development begins. Soil is conditioned to support root expansion, and grafted young trees are positioned in prepared planting sites. Each tree is stabilized and irrigated immediately to support underground adaptation. Protective measures reduce environmental stress, while roots establish structural connection with the soil. The orchard now exists as a living system integrated directly into engineered terrain. As vegetative growth accelerates, structural form is actively guided. Pruning shapes branch architecture, trellis systems stabilize alignment, and competing shoots are removed to regulate resource distribution. Irrigation and nutrient delivery respond to monitored soil conditions. Gradually, individual trees connect into continuous canopy rows designed for light penetration, airflow, and efficient long-term management. During dormancy, biological growth slows while system maintenance continues. Structural pruning preserves balance, organic residue is recycled into mulch, and soil amendments restore nutrient composition. Irrigation shifts to maintenance levels, and cover crops stabilize and enrich the soil. Mechanical systems are inspected and recalibrated, preparing both infrastructure and plant systems for renewed growth. Seasonal temperature change initiates reproductive development. Dormant buds expand into blossoms, and pollination ensures fertilization across the orchard. As petals fall, early fruit formation begins. The system shifts from structural growth toward yield production, establishing the biological foundation for harvest. As fruit enlarges, growth is carefully regulated. Selective thinning controls spacing and resource allocation, while irrigation and nutrient delivery support metabolic demand and sugar accumulation. Skin color deepens and protective surface layers form. Measured maturity determines harvest readiness, ensuring uniform development before removal. Harvest converts biological yield into transportable material. Mechanical vibration detaches ripe fruit, while integrated catch systems prevent impact damage. Conveyors remove debris and guide fruit into peeled containers. Rapid transfer from orchard to transport units preserves structural integrity and internal quality, marking the transition from cultivation to post-harvest handling. At the packing facility, fruit enters controlled unloading systems that cushion transfer and initiate cleaning. Multi-stage washing removes residues, drying systems eliminate moisture, and optical inspection classifies fruit by size and condition. Approved fruit is weighed, packaged, labeled, and palletized, preparing the harvest for controlled storage and movement. Temperature stabilization begins immediately after packing. Pre-cooling removes field heat, and refrigerated storage maintains consistent internal conditions. Continuous monitoring preserves structural and biochemical stability during transport, linking orchard production to downstream processing and distribution. Processing facilities receive the fruit as regulated raw material. Each batch undergoes inspection, sampling, and analytical verification to confirm compliance. Only approved material enters the production flow, maintaining traceability and consistency from harvest to industrial processing. Industrial sanitation removes residual contaminants before mechanical separation eliminates inedible components. The fruit is standardized into uniform processing units, enabling controlled distribution across multiple production pathways. Prepared fruit undergoes controlled dehydration. Regulated airflow and temperature gradually remove moisture while preserving structural stability. Once preservation thresholds are reached, the dried product is inspected and packaged for long-term storage. Mechanical extraction separates liquid from solid material. The extracted juice is clarified, stabilized, and thermally treated before sterile filling. Cooling and sealing complete the transformation from fresh fruit to packaged liquid product. Refined fruit material is concentrated through controlled heating until viscosity develops. Moisture reduction and sugar incorporation stabilize texture. The product is filled hot and sealed to maintain long-term stability. Clarified juice undergoes staged evaporation to remove water and increase solids concentration. After sterilization and cooling, the concentrate is transferred into sterile storage containers for industrial use. Across all production lines, laboratory systems monitor chemical composition, microbiological safety, and physical consistency. Integrated data tracking maintains standardized output across multiple product forms. After production cycles conclude, automated cleaning systems circulate chemical and thermal treatments through pipelines and processing equipment. Internal surfaces are restored to hygienic condition, preparing the facility for continued operation. Finished goods are grouped, secured, and transferred to controlled storage. Automated handling systems coordinate routing through distribution networks toward domestic and international markets.
The audio is dominated by the mechanical sounds of an industrial setting. There is this
Final products enter daily consumption while new harvests begin the same sequence of cultivation, processing, and distribution. Agricultural production and industrial transformation operate as a continuous cycle, linking land, biology, and technology into one uninterrupted system.